Hello again, thank you very much for watching this video. So in this video I will answer another question I have just received on this same channel. So the question says, hi, can you explain this if we have two methods A and B and A calls B in the same class with a Spring project, and A is transactional and B is also transactional with requires new. Why is only one transaction created? This is a really good question. Thank you very much for asking it. So it is not only about transactions. This is why this is really good. It's also about any kind of functionality in Spring, because it's an aspect oriented programming related question. So I will answer this question in this video, and I have created already a project for this, a project in which I only have added the dependencies for transactionability. I won't use any database, I won't use any complicated explanations. I only want to refer to how aspects work and how transactional works. So I have added here my Spring context dependency for that, the transactional dependencies, and I have to add also the JDBC and the MySQL connector, even if I again don't connect to any database. I just made it work, but I will explain it a little bit more theoretically in this example. So what I have created, I have two beans, A and B, and A actually auto wires B, and then we have some transactional methods. And what you can see here is that when I call method M1 from A, it calls directly a method M2 from the B class, which I have auto wired here, and it calls an M2 method from this, so from the same class itself, which is this one here. In all our cases, I have annotated the method with requires new. So what do we expect here? We expect this line will create a new transaction. This line here won't create a new transaction. Why? So this is exactly the question. Why? Why is this possible? Isn't this the exactly same thing? So why when I call the M2 method from B, which is just a normal method annotated with transactional specifying propagation level requires new, it creates a new transaction, but when I call it from the same class, so this would be like this without anything, which is basically the same as calling it from this. I would prefer to keep it like this to see exactly the actors here. In my case, this M2 is called out of this, which is this method annotated with transactional specifying the requires new propagation level. This one doesn't create a new transaction. Why is this happening? So to be able to answer this question, first of all, I will start with explaining you how this works, and then I will, for that, to prove it, print out in the console the classes that have created this object here, from which is the first object from which I create M2, and then this itself, which is the second object from which I call the M2 behavior. And this explains everything, because what you will actually see, do you expect this B to be a B class? So is this B actually B class? No. Is the second one this an A class? Yes. So the reason for why this is an A class is very clear. By Java fundamentals, we know that this is always, but always an instance of the class itself. It can't be anything else. So if I call this inside class A, I am very sure always that this refers to an instance of the class A. But B, is B an instance of the B class? No. Because Spring is enhancing it, is augmenting it. What happens here is that Spring actually creates a proxy on the B class and augments the functionality inside B class with specific functionality depending on the annotations you add upon its methods. So in my case here, if I run the main class, and I will do that, you will see that B is not B class. Just this always refers to the class itself, which is A class. The class for B is some enhancer by Spring class. Is it called enhancer by Spring because it does enhance the functionality of our application with the functionality that Spring creates? In our case, the transactionability. So in our case, this is basically the type of class. It's not B class, it's this class. A is A, but B is not B. B is actually an enhancer by Spring. B is a proxy that knows how to intercept the transactional annotation and apply the requires new propagation level, that is, creates a new transaction. Is this exactly the reason for why when you call the method from an auto-wired instance it works, and when you call it from the class itself, that is from this, it doesn't work? This is just a simple object, is our class. It knows nothing about Spring. But B is a Spring class. It's an example of inversion of control. We call it an inversion of control because it's exactly when we expect the framework to know to do something with our objects. When you use this, you will always rely on the language itself, and this in Java, it's always an instance of the class itself. It can't be enhanced. But when you auto-wire an instance, like you do here, you allow Spring to put in this attribute whatever Spring wants. And Spring won't add an instance of B here. Spring will add an instance of an enhancer, a proxy around B that not only calls the method M2, but also intercepts this annotation and applies logic like creating the new transaction, which is only happening if Spring knows about the method. If the call itself goes through the enhancer, not through the object itself. If you would go here and add another attribute in the class private AA, auto-wire it, what do you think is the difference here? If I print out A class, will this be an A class? No. So look at these two lines. One of them is using this, which this is the instance inside the class A, and that we know it's always an A class. And here I have now auto-wired an instance of the same class itself. Would you actually expect this is also A? Well, it's not, because if I have added auto-wired above it, then it will the same be as for B, an enhancer. Let's run again our application and see this. So I have run the application and now I have three system outs. One, it prints the B, and you have already seen this is an enhancer by Spring. The other one is printing this, and you have seen this is always the object itself, as we know from the Java fundamentals. And the third one prints the same A class, but auto-wired as an instance in the class itself. And you see it's again an enhancer. So isn't this funny? This is the difference. If you would call A M2 on both line 22nd and 23rd, this and this, M2 is exactly the same method as the one here. But for the line 22nd, a new transaction will not be created. On the line 23rd, a new transaction will be created. The same method, different instances. This, being the class itself, is not seen by Spring, and the inversion of control cannot happen. A, however, being auto-wired by Spring, doing that, we left Spring able to inject a proxy instead of A. And even if you don't see it, this object here is controlled by Spring. This is its magic. Spring now sees everything that happens with this object. Only like this it's able, when we call a method, to intercept such annotations and apply its behavior around it. Again, the behavior doesn't only relate to the propagation level. The functionality for exceptions, you know that when you have a transaction by default, if it is a runtime exception, Spring automatically rollbacks the transaction. And if it is a checked exception, Spring allows the transaction. This happens also because of the proxy. Any kind of other annotation you will add on the method to be intercepted itself has to go through the proxy. Anything in Spring that you add as an annotation over a method, if it doesn't go through the proxy, if the call itself doesn't go through the proxy, it has no value. So it's not the annotation itself that has the real value in this, but the fact that you have a proxy here, a spy that Spring uses to see these annotations and to be able to intercept them. It happens for transactional and all the functionality related to transactions, the propagation levels, the isolation levels, the exceptions, and so on. And it happens to any other annotation you would add and has to be intercepted by Spring. If you do the call through an object itself, which is not known by Spring, it has no value. The annotations will not be intercepted. If I do take out this auto-wired here and I only write a new A, this has no value. It's almost the same thing, but has no value, because now I have added an object of type A, which is not known by Spring, so Spring will never be able now to understand the annotations on the M2 method. It is a very big difference between writing this and writing this. Even if in the end it means that you have an instance of type A, when you do create it yourself, you will really have an instance of A. But when you do it with Spring, you will basically have a proxy that enhances a lot the way the object works. It will take everything the object does, but enhance it as a proxy to understand everything the Spring framework needs to understand. I hope with this video I've managed to help you understand why when you call the method with this it doesn't work, but when you call it with an auto-wired field it works. And I hope you understood now a lot more about Spring itself. Thank you very much again for your questions. I really love your questions, especially these really good questions, and I hope to have more questions for you soon. Have a really good time for study. Thank you very much.